Here's a little closer look at my CNC machine. The x-axis is bolted up onto these things, suspended up off of the basal platen. And it's just got this, I think it's like 4 by 2-inch aluminum pieces. Same thing on the other side. There's just 3. It seems to hold it up fairly well, so that's what it's doing. It's got a motor on each side, a stepper motor, NEMA 17, with belt drive. The belt goes the length of the machine. I've just got kind of a generic setup here, where it just sort of tensions the belt just enough to where it works, and I sort of hacked it in over here to where it's got I forget what you call these, but they're the retaining clip, I guess, one on either side for both belts. The y-axis is just 2 pieces of MDF bolted together, which I shouldn't have done because it's nowhere near strong enough. It rotates about the y-axis when you put pressure on the z-axis, which is a problem. But it's just these 2 SBR12s. That is a 600mm SBR12, and the x-axis is a 1 meter pair of SBR12s. Eventually I'm going to extend this aluminum channel all the way down the x-axis, but I didn't have enough to do that when I built the machine. I just wanted to see if it would work. Ugly wiring. There's 4 stepper controllers for 4 steppers here. These 2 have got their own, each one of these 2 has got their own controller. The x-axis motors, one of them is reversed. Just reversed 2 of the wires on one of the phases. Or did it? Oh yeah, the green and the black are reversed on one of them. So that works. These are pretty nice controllers. They'll do, I think, like 4 amps. What are you? Ouch. Oh, whatever that thing says. Get them off Amazon, they're cheap. So the y-axis is pretty simple, the x-axis is pretty simple. The y-axis is the belt's a little bit misaligned, but it still works. That's clamped down the same way. And the z-axis is a little more complex because it's got to hold up a different angle. So it's got 20 to 60 tooth gear reduction. It's got I think a 300mm ball screw. Now the interesting part is, it's also SBR12, just like the other 2 axes. And the rod moves up and down, but the linear bearings, by the way, I need to fix these because the set screw is vibrated out, but the linear bearings actually stay in one place, and the rods move up and down. And the motor actually moves up and down with it. Simulating a drilling operation right now, and of course to make all this move up and down, this is not particularly strong, but it works. You get a piece of channel bolted onto the plate, the peg plate for that, and then the motor's bolted to that, or the not the motor, well, the motor's bolted to this other piece of channel over here. Then the bearing block for the ball screw is bolted to this piece of channel. Same thing down below. Bearing block's bolted to that channel, and the piece of channel is actually sandwiched between this other plate, which acts as a support for the spindle mount that I took off my original CNC machine, which is really bad, but it does hold the spindle upright. It's supposed to. Then the ball screw bearing block is behind this metal plate that holds the spindle on. And I've got a little spacer, a little shim jammed in there just to keep it where it is. All these are tapped and drilled into aluminum. They're number 8 machine screws. Those work pretty well through SBR12. Same thing here. Kind of went crazy with the tapping because I learned I got some good taps. I learned how to do it right, and Bought some rapid tap. That stuff works great. So you can see as I move the Z-axis, it just kind of moves, and it shouldn't. It rotates around the Y-axis. And I found out that the entire Y-axis is rotating, except for the very ends. That's because this MDF is too weak, even though it's bolted together in 2 pieces. So I'm going to change that over to aluminum as well. And I took one last piece of the aluminum channel that I had to make the timing belt idler mount for the Y-axis. And around back the Z-axis, I've got a little L-shaped plate with gussets brazed in. I used Blue Demon aluminum brazing rod that works pretty good. I'm going to need to get these wires out of here before they get completely shredded. And there's just a plate that the ball screw rides on that's attached to the Z-axis by a few screws tapped into that. That's like 1/4-inch aluminum plate, most of this. And of course I made a support, this support for the Z-axis. I thought that's what was wrong, but it's not. It does make it a little bit stronger. The Z-axis is spaced off the Y-axis by 2 of these 1x1 aluminum channels, just to give me a little gives me a little extra room to work with, another inch or so. And that's it. It just kind of sits there and goes back and forth, up and down, and side to side. Hopefully doesn't break off end mills. And I don't even have all the bolts in these things. They're just, they're pretty solid though, even without all the bolts in. And these are just bolted to the MDF, the bearing blocks. That's about it. Nothing more really particularly interesting about it. Those are M5 bolts. I used those because that's the thread that the bearing blocks use, the SBR12UU, I think they're called, bearing blocks. So I just bought an M5 tap, and just everything that's near those is tapped M5 thread. The rest of the stuff, if it's not quite, doesn't need to be quite as strong, it's number 8 machine screw. I'm really glad I bought those taps and learned to do that stuff, because that's kind of cool. A little overview of the motors here. Not much to it, it just sits there and spins. And it spins opposite on the opposite side, and that means the gantry goes the same direction. I brazed that too. This motor mount, the Y motor mount, was a little bit garbage, so I just kind of made a better one. I need to get some drag chains for it. I've got those on order already. They're coming, and I need to clean up the wiring a bit and do some little bits and pieces to it, but it is a good working machine though now. Maybe get a better spindle once this Harbor Freight one has expired. But there it is. I'll see you later.